In today's session, I am going to discuss about coordination chemistry. Next video, that is valence bond theory. Valence bond theory, first definition I have written here to save the time. According to this theory, the metal atom or ion under the influence of ligands, whenever ligands approaching central metal atom, it's splitting. So according to this theory, the metal atom or ion under the influence of ligands can use its n-1d, ns, np orbitals for hybridization to yield a set of equivalent orbitals of geometry such as octahedral, tetrahedral, square planar. Whenever ligands approaching, some disturbance will be appear. So suppose in crystal field splitting, it is splitting. Valence bond theory, so geometry. So once ligand approaches, it can use ns orbitals, np orbitals, and when one is one, it can show hybridization. Based on hybridization, it give proper geometry, either tetrahedral, octahedral, square planar, like that geometries it is giving. So we have 4 examples, students. It's very easiest topic and most important topic. I will cover both competitive points, conclusions, and the next one theory examination also. So first example I am taking, this is CO NH3 6 times plus 3. This is one of the frequently asking question. Every question, I am giving 4 questions, students, totally. And CO Cl6 minus 3. And third example is nickel cyanide minus 2 complex. And fourth example is nickel chloride or else fluoride, if you wish. Nickel fluoride minus 2, we can take it. You can take it chlorine or fluorine also, if you wish. Ligands. Okay. These 4 frequently asking questions. I will explain all these 4 and with conclusions also. That conclusion points only plays important role for competitive examination. Now first one, cobalt complex. And first one, I am writing some important points here. Note points. Depends on ligand approaching, splitting will happen. Depends on ligand approaching, hybridization depends. So first one, NH3 and Cn, strong ligands. Some important note points I am writing. Note point 1, NH3 Cn strong ligand. It does not follow Hund's rule. We all know Hund's rule. What is Hund's rule? In degenerate orbitals, electrons filling first, then pairing will start. But it is not following, means instead of occupying, pairing will start. Instead of filling, pairing will start. Okay. Next, weak ligands. What are weak ligands? Out of 4 examples, chlorine, fluorine. These examples are weak ligands. Weak ligands follows Hund's rule. Clear point. Now we look into the points. First example, cobalt I am taking. So here finally 5 points I am explaining. All 5 points, listen. Make a note. CO NH3 6 times plus 3. Okay. Now here first step is calculate oxidation state of central metal atom. What is the central metal atom? In the previous video I had explained what are the central metal atoms and all. So this is cobalt, central metal atom. So cobalt plus 6 into 0 equal to plus 3. Okay, now cobalt equal to +3. In competitive examination, you no need to calculate this method. Just it is neutral ligand, right? Neutral ligand, what is the charge here? That is only your answer. Now step 2. Step 2. So cobalt +3 oxidation state. Cobalt +3 oxidation state. Cobalt +3 oxidation state means it's take electronic configuration and we can show all the points. Cobalt +3 oxidation state. Cobalt capital C, small O. CO same, both are same size, that is carbon monoxide. Okay, cobalt +3. Cobalt +3. What is cobalt atomic number, students? Yes, 27. What is its atomic number? 27. What is electronic configuration? Yes, argon 4s2 3d7. Very easy way had explained D block elements configurations. Please go through that if you have any doubts. Now look into this. Here, cobalt is giving information to us. He lost 3 electrons. He lost 3 electrons. Where it lose 3 electrons? Where he lost 3 electrons? Definitely outermost shell. Outermost shell is highest principal quantum number. Here 2 electrons. Here 1 electron going. So now rest is students 3D. Yes. 3D, argon 3d6. Argon is completely filled electronic configuration, you no need to take. Finally 3d6 electronic configuration we are seeing. Now ligands approaching. So before going to the third point, everybody make a note here. Ligand type. NH3 is strong ligand. NH3 is strong ligand. It does not follow Hunt's rule. It does not follow Hunt's rule. Does not follow Hunt's rule. Okay. Now see students, actually 3d6. 3d6 means we have expected 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 we have expected, but it is not following. How it is following? Check it. How it is following? I am writing here 3d6 pairing. Without filling, pairing will start. Yes, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's it. This is NH3. NH3 is strong ligand. This is filling like this. Now, ligands. How many ligands in our hand? What is the complex? You can look into the complex once again. Here I am writing NH3 6 plus 3. This complex only, here 6 ligands in our hand. Each ligand, how many electrons it can donate? Each ligand donate 2 electrons. 2 electrons. 2 electrons it is donating means we have to provide 6 vacant orbit. How each ligand 2 electrons, but how many ligands? 6 ligands. 6 2s are 12 electrons. Totally 12 electrons it is ready to donate. That means 6 vacant orbitals we have to provide. 6 vacant orbitals provide. One is unpaired. Unpaired electrons we should not, unpaired electrons box we should not provide. Why? Because each ligand is giving 2 electrons. Always you have to provide empty. Now I am drawing here structure and electronic configuration I am writing. Check it. 1, 2. Okay, this is what students? 3D, right? 3D6. 4s. I am providing vacant orbital. For that I am using next orbitals 4s, 4p. I said above is a definition n minus 1d, ns, np they are taking like this. This is n minus 1d, ns, np. Now 3d6. 1, 2, 3, 4, 5, 6. 6 ligands donating. 1, 2, 3. How many vacant orbital? 1, 2, 3, 4, 5, 6 vacant orbital provided. That's it. Okay. Now, what is the hybridization? D2, sp3 hybridization. D2, sp3 hybridization. That's it. 2 d orbitals, 1 s orbital, 3 p orbitals involving d2sp3 hybridization. That's all, students. This is hybridization. Now conclusion points. These are all conclusion points finally important for our competitive examination. Conclusions. First one, D2sp3 hybridization. D2sp3 hybridization. Now next one, what is the, students? Next one, we have to write, is it paramagnetic or diamagnetic? See, there is no unpaired electrons, or all are filled. This electron, these two electrons are same only, but ligand giving electrons just I mentioned in different way. That's it. So both are same. So this is diamagnetic. No unpaired electrons, diamagnetic. If it is diamagnetic, definitely it is colorless. These are all points already we have studied in D block elements, right? Next, fourth conclusion point. He started from D. He started from D. D hybridization started. That means it started from D means we have to write inner orbital complex. It starts with S means outer orbital, inner orbital complex. And the next one, it is low spin. There is no spin. No, when spin is more, unpaired electrons is more, then freely rotating spin is more. Here low spin complexes because all are paired. Now, next one, last point, N equal to 0. That means unpaired electrons is 0, mu also 0. That is magnetic moment is 0. Next one more point. Structure, shape and structure. That is also important. Let me complete. Octahedral shape. Structure. I am going to draw the structure. Cobalt. Yes. Donating electrons, no, we can write like this, D2 bond. Starting introduction part also I had explained D2 bond. NH3. This is NH3. First we have to draw square planar. After that we have to draw above and below the plane ammonia molecule. So that's it. This is NH3. This is NH3. This is NH3. This is also NH3. That's it. So this is finally octahedral, but we have to write the charge. So with this we have completed both put examination IP and this is PUC, CBSE all, and then competitive questions also. Now next question. CO, another complex. You may take Cl6, you may take CF6 also, both. Second question. CO, Cl6, what is the, students? -3 minus. Then first step is oxidation state, calculating oxidation state. CO plus 6 into -1 equal to charge, equate to the charge. Then CO minus 6 equal to -3. Then CO equal to +3 oxidation state. Clear point? Now first step completed. First step, second step same, right? Above case and this case. Now cobalt +3 oxidation state. +3 oxidation state is nothing but argon. Tell me, students, 4s2 3d7, right? Cobalt, what is this oxidation state? 3d7. So gone here. Here one electron gone. What is the rest here? 3d6. Yes. Next important point is weak ligand or strong ligand. This is weak ligand. Cl6 is weak ligand. Weak ligand means it follows Hund's rule. That is the difference. So Cl is weak ligand. Cl is weak ligand. It follows Hund's rule. That's it. Now can you write what is this answer? Yes, 3d6. 3d6 means 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's it. Now, in how many ligands is there? How many vacant orbitals we have to provide? Students, take one more time complex. So, what is this complex? CO, Cl6, yes, minus 3 or 3 minus. 6 ligands are donating electrons. 6 ligands are donating means how many vacant orbital we have to provide? 6. 6 vacant orbitals we have to provide, right? So 6 vacant orbitals, this is P, okay, this is 3D, this is 4S, this is 4P, still we need, then that is D, 1, 2, 3, 4, 5, this is 4D. Clear? Now 6 we have to provide. Here one ligand is giving, second ligand, third ligand, fourth ligand, fifth ligand, sixth ligand. This is what finally sp3d2. One s orbital, 3 p orbitals, 2 d orbitals, sp3d2. So now finally conclusion points, conclusions. First one is sp3d2. sp3d2 hybridization. Now second point. What is the second point, students? This is paramagnetic or diamagnetic. Unpaired electrons is there. No? Unpaired electrons is there means it is paramagnetic. Paramagnetic, and it can show color. Color. Next, fourth point. What is the fourth point? Can you tell what is the fourth point? Yes, outer orbital complex or inner orbital complex. This is outer. It started with S. This is outer orbital complex. Outer orbital complex. Now next one, fifth one. What is the fifth one, students? Yes, magnetic moment. How many unpaired electrons is there? N equal to 4. N equal to 4 means mu equal to 4.8 Bohr magneton. Already we have discussed, right or not? So if you want to refer magnetic moment, how to calculate, what is the trick I had given, please go through the D and F block elements video, students. Next, sixth one. What is the sixth point here? This is also octahedral. This is also octahedral. Next, is it high spin or low spin? High spin, more unpaired electrons is there. This is high spin. Sometimes in examination they will ask differences. Suppose theory examination is there, differences between first two cobalt complexes. Then you can write final conclusions. That is 7 points there, 7 points here. That is the differences. That's it. Now example 3. What is example 3, students? Do it fast. Nickel cyanide. Okay, Cn4 minus 2. Right? What is the nickel atomic number? Sometimes in examination they are not giving atomic numbers. We have to remember nickel. First step. What is the first step, students? Calculate oxidation state. Nickel. What is the oxidation state here? What is the oxidation state? Nickel plus 4 into minus 1. See, this is ambidentate ligand or unidentate. It donate finally one donor only, like unidentate we can call. So that is equal to the charge. Nickel minus 4 equal to minus 2. Then nickel equal to plus 2 oxidation state. Plus 2 oxidation state. That's it, students. Now what is the second step? What is the second step? What is the second step here? Tell me. Yes, nickel plus 2 oxidation state. What is the nickel atomic number? 28. What is the electronic configuration? Argon 4s2 3d8. Here plus 2 means here gone electrons. What is the rest here? 3d8. 3d8. Now third step plays important role. Whether it is strong ligand. Strong ligand. Strong ligand means it does not follow Hund's rule. I have written starting one important point, right? So write down Cn minus is C donor strong ligand. Cn is strong ligand. It does not follow Hund's rule. It does not follow Hund's rule. Hund's rule. Clear? That's it. This is what 3D8. 3D8. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. That's it. Now, how many ligands in our hand? Next step, cyanide. 4 ligands. 4 ligands is there, right or not? That means 4 vacant orbital we have to provide. Already it's there 1 and remaining 3 we have to provide. This is what 3D. This is what 4s. This is what 4p. Then ligands. 2 electrons. Here 2 electrons. Here 2 electrons. Here 2 electrons. That's it. Only 4 ligands are there, right or not? Only 4 ligands are there. Then we have to provide 4 vacant orbital. That's it. So can you tell what is the hybridization? Yes, DsP2. DsP2. Can you write final conclusions? Write it down. Final conclusions. First point, what is the students? Hybridization. Yes, DsP2 hybridization. And the second point, what is the second point? Second point, what is the conclusion? Yes, it is diamagnetic. Same like first case. Strong field diamagnetic. And the third point, what is the conclusion? Third point, is it outer orbital, inner orbital? It started with the D. That's why we call it as inner orbital complex. Next point, fourth one. What is this? Colorless or color? Colorless. No unpaired electrons. Okay. Now next one. Magnetic moment. What about N here? N is 0. N 0 means even magnetic moment also 0. Right? That's it. Now what about the sixth point, students? What about the sixth point? It is square planar shape. It is square planar shape. Is it outer orbital or inner orbital? Inner orbital we have written. Next last point I am writing here. Seventh point. What is the seventh point, students? Yes. High spin or low spin? Here no unpaired electrons. Then we call it as low spin complex. Low spin. That's it. We have written all conclusion points, right? Then move on to the next one. Last one. In today's video, the last topic, nickel. Yes, chloride. Can you do along with me? Nickel chloride, Cl4. What is this? 2 minus. Even F also. Sometimes to confuse the student, fluorine they will give. Both are same. Both are weak ligands. Next, first one. What is the oxidation state? What is the oxidation state? Nickel plus 4 into minus 1 equal to minus 2. Next, what is this oxidation state, students? What is this oxidation state? Excuse me. Nickel oxidation state. Nickel minus 4 equal to minus 2. Then nickel equal to plus 2. That's it. Now what is this next step? Nickel electronic configuration we have to take it. Nickel atomic number 28. Argon plus 2 is nothing but last 2 electrons, same like above case, last 2 electrons, rest is 3D8. That's it. Now third point. What is the third point? Ligand is. Ligand, what is the ligand type here? Yes, it is weak field ligand. Weak ligand. Weak ligand. What is that ion? Chlorine. Weak ligand chlorine. It follows Hund's rule. It follows Hund's rule. That's it. Now write down. It follows Hund's rule. Then 3D. You can take the same thing here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Next, S. This is S. And how many ligands we have to provide, students? Now nickel, what is the complex? Can you write one more time here? Nickel flow Cl4. This is what? -2. We have to provide 4 ligands. 1, 2, 3, 4. That's it. What is this hybridization? sp3. Yes, very good. With this we have completed all the examples. Finally, last example conclusions I am writing, students. What is the conclusion? First one, sp3 hybridization. sp3 hybridization. Next one, what is this? Is it paramagnetic or diamagnetic? Paramagnetic or diamagnetic? It is paramagnetic because 2 unpaired electrons are there. See, check it, 2 unpaired electrons. This is paramagnetic. Next one, it is outer orbital, inner orbital. Outer orbital complex. Outer orbital complex. Next, what is this? This is second point. This is the third point. Fourth point. Color or colorless? Definitely it is colored because unpaired electrons are there. Now fifth point. Fifth point, low spin or high spin? This is unpaired electrons is there. Now when compared to third example, fourth example, high spin. Right? High spin complexes. More unpaired electron, more spin. Now next one, what is the next point, students? N equal to 2. Then magnetic moment is 2.8 Bohr magneton. Same value, same number, 0.8 you can add. Then seventh example, it is tetrahedral shape. Tetrahedral shape. I am going to draw the structures also now. Even above cases also we can draw. What is this nickel? Tell me. Tetrahedral. Nickel is the central atom. Here chlorine, here chlorine, here chlorine, here chlorine. That's it. We have to write the charge of this tetrahedral. Is it clear? Even above example also try to draw the structures. What is the student? Square planar. We have to draw square planar shape. Can I draw here? Square planar. Yes. Square planar. Nickel. Here, what is this? Cn. Here, Cn. Here, Cn. Here, Cn. This is square planar. That's it. And what is the charge here, students? We have to draw the charge also 2 minus. Now, next one. First complex we have drawn already structure. Right? Now, next one. What is this? Cobalt Cl6. Yes, this is also octahedral. Can I draw structure here? CO. Cl. First see square planar you can draw. Octahedral means on paper 6 only. One top, one bottom it's there, that no need to draw. Cl. Next to Cl. That's all guys. Then finally what is this? -3. 3 minus. This is the conclusion points finally. And above case already we have taken. Right? Already we have drawn the structure. So octahedral there and here also. Have you taken structure here? Yes. This is structure. So with this VB theory successfully completed. This is one of the most important competitive question and board examination also. Thank you students. Thanks for watching. Please subscribe our channel and share to all your friends. And thanks for watching once again.